The next section, 4.6, is relatively quick, and that's good because a bell is about to ring. 4.6 deals with describing reactions in solution. So you guys are used to the formula equations. Another name for those is molecular equations, and these are the ones that give the overall what's going on in the reaction, but not really specific information about the states of the reactants and the products when they're in solution. In general, you only show the reactants and products as compounds, even if that may not be true. So when you are trying to describe what's going on with a reaction in a solution, you need to look at solubility rules to determine which compounds are aqueous and which ones are solid. All right, so an example is silver nitrate and sodium chloride. Both of these are aqueous solutions, which means they are ions in water. They will combine to form a solid, this is a precipitate, silver chloride, and aqueous sodium nitrate, which means these guys are ions. We call a description of what's going on in the reaction solution a complete ionic equation. And when we are making these, we need to take all the substances that are strong electrolytes and represent them as ions, because that means that they are free floating in the solution. The strong electrolyte, these are things that conduct electricity efficiently. So you could you could shine a light bulb very brightly with a strong electrolyte, and I can show you what I mean by that in class. These are completely ionized in water. So according to your solubility rules, strong electrolytes are soluble in water. Weak electrolytes only can conduct electricity with a small current. A light bulb would glow dimly, and they are only ionized to a small degree in water. So these would be slightly soluble. Non-electrolyte, there is absolutely no current flow. These are things that dissolve in water, but they do not produce ions at all. So if we were to take the reaction from the previous slide and break it down into the complete ionic equation, we would have silver ions and nitrate ions, because silver nitrate was represented as aqueous, so that means they are both going to dissolve in water. And then we would also have sodium and chloride ions, because that was also represented as aqueous. According to our solubility rules, we should be able to recognize that silver and chloride will combine and precipitate out, forming a solid, but that sodium and nitrate are not going to have a reaction, so they are going to be ions in water. The net ionic equation is going to be the one that only includes the components of a reaction that are undergoing a change. So in this situation, we would only show our silver ions and our chloride ions going to form silver chloride as a solid. You do not include spectator ions. Remember, spectator ions are ions that are not participating in the reaction itself. So that would be sodium and nitrate. They would not be included. Let's look at an example. Write the correct formula equation, complete ionic equation, and net ionic equation for the reaction between cobalt-2 chloride and sodium hydroxide. Pause it here and think about it. Okay, when you are doing a problem like this, the first step is to write out the formula equation. So that would be the reaction between cobalt chloride and sodium hydroxide. You would write that out first. And sorry, the arrow is up high. I tried to move it and it just made me mad, so I left it there. So cobalt chloride and sodium hydroxide both are aqueous solutions. They're going to combine to form cobalt hydroxide and sodium chloride. I think I might have misspoken earlier. So cobalt chloride and sodium hydroxide combining to form cobalt hydroxide and sodium chloride. Remember too, it's very important that you balance the equation. Now the complete ionic equation, that would be breaking off everything that has an aqueous designation out into their ions as they would be in solution. So cobalt and chloride, sodium and hydroxide, all of these things are in aqueous form. So in a complete ionic equation, you would represent them individually. On the product side, cobalt hydroxide is a solid, so that stays together, but sodium chloride was aqueous, so you would break them apart because in a solution they are not actually bound together. The net ionic equation is the one that includes just the components that are undergoing a change. So that would be the cobalt and the chloride. Wait, that is not right. It would be the cobalt and the hydroxide going to form cobalt hydroxide. So let's just pretend that it doesn't say 2-chloride down there, that it says the 2-hydroxide. And that ends section 4.6.